So here I'm going to talk about the concept of elasticity, which is really important in microeconomics. Basically, it looks at the relationship between price changes and quantity changes, and it's not the same for every product. Okay, so you have to really understand what the demand curve looks like. And what it means for businesses is if you set the price wrong, you might actually lose money by raising the price, or you might make money by lowering the price. It depends from product to product, and the number you calculate for elasticity will tell you what happens if you raise or lower prices. Okay, so we already know that demand curves slope downward. And if you lower the price, you're going to make more money. You're going to get more customers. Excuse me. We don't know you're going to make more money yet, but people assume that because if you lower the price, you get more customers, right? That should be more sold. But the problem is you'll lose money on what you sell, and you might not make enough customers to offset that. So revenue is price times quantity. This is going to be negative. You're going to lose money on price, but you're going to make some money on quantity. But is it enough to make money overall? All right, which effect wins, the lower part or the upper part, the decrease or the increase? A different kind of curve would actually have, I could draw it down like that, and it would be inelastic. You might actually have not enough quantity increase. You might have lower revenue. Right, so we're going to use this concept, lowering the price raises quantity, but we don't know the numbers yet. We get the numbers, and we're going to get a number for elasticity that will tell us what happens to revenue if you increase or decrease prices. Okay, now because this is a downward slope, it's always negative. So I drop the negative sign, and I just deal with absolute values, so I've got positive numbers. That's not the same in every class. You might be looking at -1 instead of 1, right? But that depends from class to class. But basically, if you've got the top part, the numerator, and the bottom part, the denominator, if I do have a big quantity increase, that's going to help me make money on volume, and the top is bigger than the bottom, this ratio will be greater than 1. And so if elasticity is greater than 1, revenue will go down if price goes up. And if you flip it, revenue goes up if price goes down. Okay, so that's elastic demand greater than 1. Revenue goes down if price goes up. Now, what if this is small? If you were to say, let's say you raise the price, and you're going to lose some customers, but not that many customers, right? So you're gonna keep most of your customers, and you're gonna charge them more. Revenue will go up if price goes up. And generally speaking, elasticity has to do with the availability of substitutes. And if you think of it that way, I raise my price, I lose a lot of customers because they have somewhere else to go. I'm going to lose revenue overall. But what if I have a product where my customers have nowhere else to go? I'm going to raise prices, and they're going to stick with me, so I'm going to charge them more. I'm going to make more. So you can think of different types of businesses. I think of restaurants and things that's elastic, and then you think of like gasoline, and stuff like cigarettes and tobacco that they, alcohol, things people tax. This is inelastic. People will stick with it. People still drive if you raise the gas tax. And so inelastic demand means you make more money with a revenue increase. Right. There's also, if it's exactly 1, you can call it unit or unitary elastic. And then infinite elastic, perfectly elastic is if this infinite, right? Not just greater than 1, but it's positively infinite. You can also have 0, which is perfectly inelastic, and I'll show you those curves. There's a couple different types of elasticity. I didn't mention elasticity of supply here, but that's a fourth one. Own price is what I call it. It's the main one here. It's basically the price of a good and the quantity demanded of the same good. But you can also do cross-price elasticity, where one price goes up and a related product changes. Okay, so these could be substitutes or complements. Okay, you might know those terms. Basically, if I raise my price and your quantity goes up, that means my customers are going to you because we are substitutes. So my price increase, your quantity increase, it's the same sign, they're both increases. That means that this is a positive number. But what if I raise my price and I hurt your product? Maybe it's because they're used together, they're complements. So increase here, decrease there, opposite signs, that's going to be a negative number. So those are complements. So that's how you can tell substitutes and complements. And notice that these turn on 0, not 1. Okay, it's positive or negative. Same thing with income elasticity. This means that if a country's income increases, it might lead to an increase of my product being sold. That's a normal good because they're the same direction. They're both increases. It's positive. But inferior goods are things like cheap cuts of meat and so forth. You might see that in the textbook. People talk about specific examples. But what happens if income increases but product goes down, right? People are buying less of the product when they have more money. So that's negative. People also look at the size. So in international economics, I talk about agricultural products. Basically, when countries get rich, they eat better food, but eventually they max out at a full diet, and they can't keep eating food indefinitely, so they have to switch to manufactured goods. So people can have, you could have 100 cars in your garage, but you won't eat 100 meals a day. Basically, higher income does not increase food consumption as much as it does the consumption of manufacture. So I use that in international economics. But today I'm basically going to talk about own price elasticity. So I look at it right here as the steepness of the curve. Now, you're going to get a different number with every point. You also get different numbers if you go up versus down. And so I notice I did not use the midpoints formula. If your class requires it, you should learn it. I don't always cover that. I'm especially not going to do it here. But because you get different numbers along a range, you're going to wind up with different numbers, whether you have a big increase or decrease, or if you go up or down. The midpoint takes the average of the range. So it's the same if you go up or down, okay? And also you might actually look at how it turns from elastic to inelastic across the middle. I'm just looking at the overall slope, and I'm just going to get up a couple of points. Steep is inelastic. Not so steep or flat is elastic. Okay, in other words, a price increase here, a price decrease will be a huge loss in customers. Here, if I raise the price, it's a huge loss in customers. If I raise the price over here, it's not going to be such a big loss of customers. I can go the other way and say, well, what if I lower my price? If I lower my price, I gain so many customers, I'm going to make money. Here, if I lower my price, I'm not going to gain that many customers, so I might not make money off of that, right? The other one we're going to see a lot is perfectly elastic. And you see this in perfect competition. In other words, this is infinite. If I raise my price even a penny, I lose all my customers. Right? So I have no market power. This one is inelastic. This basically says that the quantity doesn't change. Okay, I can't change the quantity. This one doesn't come up so much. Here's unit or unitary elastic. This is exactly curves that if I lower the price, I'm going to make up the exact amount of customers to offset. And so the elasticity is exactly 1. Okay, there's no effect. So this is looking at it in terms of slopes. So here I've got inelastic demand, and I've got 3 points. I got a price of 5, price of 4, and a price of 3. These are not percentages. I'm just going to go down by $1. Now I just want to point this out real quick. If I go from 5 to 4, that's a 20% decrease. But if I go from 4 to 5, same numbers, 4 to 5, 25% increase. That's why you use the midpoints formula, because it's actually different percentages if you go down versus up. But I'm not going to worry about that right now. I'm just going to calculate revenue. At a price of 5 in red, revenue is $17.5. And that because that's a quantity is 3.5. Quantity is 3.5, and you get 17.5. But if I lower the price to 4, right, I'm going to lose money on the price, but revenue is going to be 16. And that's because quantity is 4, right? So 4 times 4 is 16. If I lower the price another $1, revenue goes down. And so within elastic demand, lowering the price lowers revenue, raising the price raises revenue. All right. You can look at it in terms of rectangles too. If I go from 5 to 4, or my original revenue is this red rectangle. And if I lower the price to 4 from 5, I'm going to lose this part of my rectangle. I lose the top part. I slice this off. That's a loss. But I gain this part here. Right? So and if you calculate the numbers, I lose $3.50 at the top. And you think, well, this looks bigger. But it's actually not. You have to calculate it mathematically. And this is only worth $2. And the net, because the loss is greater than the gain, I lose $1.50. And that's the $1.50 from $17.50 to $16. So here, lowering the price lowers revenue. It's a smaller rectangle. If I go the other way, raising the price will raise revenue. Now with elastic demand, here it's from 8 to 7 to 6. You can calculate it here. Lowering the price from 8 to 7 raises the quantity from 8 to 10. And so my revenue goes from 64 to 70. By lowering the price, I'm going to actually make more money. All right, and so that's the big difference in terms of revenue. When I say make money, I'm actually making revenue. Lowering the price raises revenue. Raising the price lowers revenue. All right, and I can do the same thing with the rectangles. I'm going to slice off the top and lose $8, but I'm going to gain 14 on the side. So I'm going to actually gain this $6 over here. Okay. Now unitary elastic, basically I'm going down by a certain percentage. All right, I didn't show the numbers here, but these exactly offset the revenue here. And that calculated this curve. It's always $32. Okay, so revenue is unchanged. It's always, no matter what the price is, it's $32. Now it's perfectly elastic. Again, this is going to come up. You can't change the price. you're only going to change the quantity. So if I increase from 6 to 7 to 8, I'm only going to make $6 each. So every time I increase quantity by 1 unit, revenue goes up by $6. So marginal revenue, the revenue from one additional unit, is equal to price. So here are some examples. Now this goes back to the first curves, the inelastic demand curve. I lowered the price from 5 to 4, and going in this direction, it's negative 20%. Quantity goes up, right? Because I lowered the price, but it only goes up from 3.5 to 4. That's 14.3% if you take the ratio percentage change in Q over percentage change in P. 14.3 over 20 is 0.714. It is less than 1. It is inelastic. And we saw that. It was showed inelastic, and the revenue went up if we raised the price and went down if we lowered the price. Now, on the second curve, we had inelastic demand. So here, we're going to lower the price from 8 to 7. That's a 12.5% decrease, right? Because it's a change of 1 over 8, new minus old over old. 7 minus 8 over 8. 1 over 8. So that's a 12.5% loss. But quantity goes up 25%. It goes up by a quarter, right? It goes up by 2, which is a fourth of 8, right? So that's a 25% increase in quantity. So percentage change in Q over percentage change in P, 25 over 12.5 is 2. So the elasticity of demand is 2, which is greater than 1. It's elastic. So these are the things that I drew out on those examples, right? So with those numbers, you can actually figure out at that exact point, it's inelastic for the first one and elastic based on not only what I wrote inelastic, but the number is less than 1. Now, what economists do is they actually take points, right? If you use calculus, everything's at a point. And so there's no difference what direction you go. There's no range, and so you can actually do it a little more precisely. And you can use those tools, but here you kind of can get a sense of relating the steepness of the whole curve with the slope, right? Remember, in calculus, you get the slope at a point, which is the derivative. Here, it's simply looking at, I'm just taking one point and showing you a steep curve versus a flat curve. Right. Now, just a couple quick examples of the other types of elasticity. You can have cross-price elasticity. If X raises prices 5%, quantity of Y demanded drops. So I raise my price and it hurts you. You can say, well, 3% over 5%, quantity over price, 3 over 5, is negative 0.6. Now, you cannot drop the negative sign here, right? So this drops is important. It's basically 0.6, okay? It is negative. X and Y are complements. Now, what happens if X raises prices 5% and quantity Y demanded increases? In other words, I raise my price and I help you. I help you, right? My customers are going to you. We are substitutes, all right? So you think of it conceptually, right? If I raise my price and it helps you, it's because my customers are going to you because we're substitutes. Now, you can look at it with the formula. This is plus 5, this is plus 10. And remember, this is the Q over P, right? 10% over 5% is 2. All right, so elasticity is positive, meaning we are substitutes, right? So that's where the positive and negative come in. With income elasticity, what if a country's income increases by 10% and the product X demanded drops, right? So in other words, richer people are buying less of a product. You can say it's negative 0.3, all right, 3 over 10. That is inferior because it's negative. Right? But what happens if income increases by 10% and the quantity of X increases by 5%? You can say 5 over 10 is 0.5. It's positive, so it's a normal good. Now, you can look at the size as well. Like I said, agricultural elasticities might be smaller than manufacturing. You can look at things like luxury goods. Sometimes people, buy more of something. Sometimes people respond weird to demand. So I'm not going into the weird cases, like what happens if people buy something just because it's expensive or things like that. So I'm just kind of hitting the main points of substitutes, complements, inferior goods, normal goods, and you can do it by looking at the positive and negative elasticities. Now, so given some percentages, you can actually use the formula, percentage change in Q over percentage change in P. You get a number, and then you interpret it by looking at the sign. You say, hey, it's negative. Negative income elasticity is an inferior good, right? But the big one was the big one is own price elasticity. Now, looking at the whole curve and just kind of imagining that the world looks like this, or this whole product looks like this, just at the point I'm showing, you can say the increase in customers here offsets the loss in price. This company actually has a better strategy to lower prices and to make money on volume, right? That is not true for inelastic demand, where lowering the price might actually hurt revenue. So companies with inelastic demand might actually have a better strategy to raise prices. So businesses, banks, and stuff actually will calculate elasticities, and knowing your product will actually help you pick the right pricing strategy, right? But for here, you should be able to calculate the formulas using percentage changes. You should be able to look at whether something is infinite or greater than 1, equals to 1, less than 1. You can actually think of the implications on revenue, and then you can use elasticity to see what happens to a business with changes in price.